Welcome to the presentation of the 3D particle view. In this video we will show you what the 3D particle view can do for you and which improvements will result for you. What is a 3D particle view? It is a system for optical particle measurement to optimize particle properties. We will show you how the system works and how you can benefit from the information it provides in the following minutes. Why are particles measured? The particle geometry is a decisive parameter for the mechanical properties of particle board. Particle length, width and thickness have an influence on the characteristic values of the finished board. Furthermore, the particle surface in relation to the volume is a decisive parameter for the effectiveness of gluing and the amount of glue used. The characteristic values and the required amount of glue are thus influenced by the size of the particles. The size of the particles, in return, depends on the settings of the knife ring flaker and changes with the wear of the knife protrusions in the knife ring. Let's first look what the conventional laboratory work looks like for particle quality control. The most common is the sieving method. A particle sample is taken after the knife ring flaker and sieved in the laboratory. The weight of the individual fractions is then determined. The result, however, only indicates the width of the particles. Another disadvantage is the time required for sieving and the subsequent analysis. Additionally, the measuring results depend to a large extent on the sieving time. Another method is a manual measurement of the particles. This method is also very time-consuming and only a small sample can be examined. Moreover, the operator's influence on the measuring results plays a role here. Due to the efforts involved and the possible measuring errors, both methods are only suitable to a limited extent to supply sufficient and reliable data to optimize the particle properties. How does the 3D particle view work? The procedure is very simple for the operator. All that needs to be done is to put a particle sample of about 6 to 8 grams into the vibrating chute of the measuring system, although larger particle quantities are possible. The particles are automatically separated and then transported by a conveyor belt through the optical measuring unit that measures all 3 dimensions of the particles fully automatically using a combination of a line laser and camera unit. Depending on the sample quantity, the system needs about 3 minutes to measure a sample. In addition to measuring particle length, width and thickness, volume and surface are determined from the recorded 3-dimensional data. No assumptions are made. The data obtained is clearly visualized. Especially due to the increasing proportion of recycled wood, it is important to permanently determine the particle geometry. Besides the knife protrusions, it is particularly the type of waste wood used that has a decisive influence on the geometry of the particles and thus on the properties of the board. Furthermore, the wear of the knife rings depends on the type of waste wood, which again also influences the particle geometry. By permanently measuring the particle geometry, it is possible to optimally adjust the downstream processes and the change of the knife rings. The main screen shows the detected particles in a wrong color view. The different colors represent the thicknesses of the particles. The other displays are for data processing and further analysis of the measurement. The table view allows to call up measuring results and individual particle data and also an export to CSV file for further analysis. A PDF report can be individually configured regarding the printed parameters and the axis division provides a quick analysis of the measuring results. For example, the proportion of particles of a certain thickness, length and width of the total volume of the sample is displayed. The 3D particle view is preferably used in the laboratory or in the machining control room. The distances are short here and the data obtained can be used immediately. The convincing benefits of the 3D particle view are consistent measuring results as operator influence is eliminated, data on all 3 dimensions of the particles, enormous time savings as measurement is fully automatic, quick influence on the cutting process and thus on the particle geometry. Optimization of the point of time when changing the knife rings. The available data can be combined with other process data and used for statistical evaluations and quality control. It is particularly the cost savings that can be achieved with the 3D particle view that are to be emphasized. They were proven for the use of adhesives and for screening losses. Especially the screening losses can be shown very well. Experience has shown that the screening losses can be reduced by up to 1%. The following model calculation shows you the possible savings for 1 year. The calculation assumes a chipping capacity of 20 tons per hour. This results in a material saving of 200 kilograms per hour. Assuming 23 operating hours per day and 330 production days, this results in a material saving of around 1,518 tons, extrapolated to 1 year. Assuming costs of 100 euros per ton of particles produced, the saving potential achieved with the 3D particle view is around 152,000 euros per year. Gluing optimization delivers a further savings potential. The continuous analysis of particle geometry enables a change from gluing based on mass to gluing based on the particle surface. Studies show that gluing savings of between 1 and 2% are possible. With this film, you gained insight into the optimization and savings potentials that are possible with the 3D particle view. If you have any questions or requests, please do not hesitate to contact us. We look forward to receiving your inquiry.